one of our colleagues tried to play poker with ChatGPT's assistance and ended up losing quite badly.
ChatGPT came around, I was circumspect of the technology and I was not using it. The first time I used it was during my interview process.
Be a busy manager and then critique, and it actually gives out a pretty decent answer.
That's why it lost at poker. So we should not be using it at poker. How do we make sure that when they are coming on board, they're thinking about AI as a companion that goes beyond just helping them automate some code?
How I use is that it is as a companion. It is actually sitting out there. You can literally ask it to do any kind of research, refine anything that you would want.
Just keep verifying things. I would say short, sharp blurbs. You can ask LLMs to do it, but then keep checking it out.
Let's say engineering graduate that is coming out, and how should they think and perceive LLMs as a capability, and given how fast it's growing?
Modeling the domain knowledge to embed into an LLM. What does it take? How do you model it? That's the key piece.
And you don't have to really write any more rules. You just have to, all you need to really do is to train a particular model, or you just use some of the frontier.
A few months ago, LLMs were a lot better at Python than sort of other languages, right?
Process of how to do it is still evolving. We do not have a handle. But that's the work in place. LLMs will become the interface to interact with the models that form that fat tails or fringe or whatever you want to call it.
I think before we get into the more serious stuff, we have to touch upon some of the fun instances that we have all at some point experienced while using LLMs. A few days back, we had a poker night in this very office on this very table, and I won't name, but one of our colleagues tried to play poker with ChatGPT's assistance and ended up losing quite badly. And he said that that's the last time we're going to use ChatGPT for anything outside of work. But I'm sure you guys would have had some fun experiences, maybe Sumanth.
So one of the things is that LLM tends to agree to whatever you say. Let's say you take a question and you basically give a set of facts and ask anything. Whether there is anything, even a minute detail, it tends to agree. But actually, you can actually fix it. We came up with something called as a critique mode. And the name is a little bit different than what I give it. I give it a profile called, of course, it's a critique mode of anything that you are actually trying to do. But I give it a name called, it's very famous in my team. It is called as a BT manager. Of course, it's a little bit hard, but if you really use this particular term, be a BT manager and then critique, then it actually gives out a pretty decent answer. But it also at some time really traces that you have done a really pretty decent job. So this very profile of a BT manager really works very well.
I'm not going to ask you how someone stumbled upon or actually crafted this as a prompt or grounding the persona. But I don't know if Madhu, you or Prathamesh, you guys have had any of your fun experiences.
So interestingly, I mean, when ChatGPT came around, I was circumspect of the technology and I was not using it. I would say I was quite late to use it. The first time I used it was my assignment so during my interview process. So Madhu had crafted some questions and this was a take-home thing. I had 2 days to do it. So I just wanted sort of a high-level ideation of what do I need to sort of use. So I used ChatGPT.
Must have been 3.5.
Yeah, 3.5. Yeah. And it gave me this very nice report, gave me references. So I start looking up the first reference, nothing came up. Second reference, nothing came up. And then I realized it just making up stuff.
It is me.
Yeah.
So the reason we hired you was for your own work, not ChatGPT.
Yeah, I did eventually have to use like,
your own brains to do that. Madhu, any fun?
For me, some of the experiments I've done with ChatGPT, one of the fun ones is when you have a recipe, let's say you don't have ingredients at home, what are the best substitutes? Right.
Does it work properly for that?
No. It makes up things. A lot of it. Veg becomes non-veg, this becomes that, right? So it's very interesting. So then you really have to be careful to look at the output. Just a lot of fun things you can do, but actually people need to be in the loop to make good use of it.
Yeah.
So
I think all of us and the wider team as well, we have been using various kinds of LLMs for different use cases. The first thing that I wanted to kick off with was how should we think about LLMs? And I think generally when we think about LLMs, it's not just autocomplete, it's not just next token predictor, it's not just a conversation layer. It's also increasingly becoming a very important subsystem in various architectures, various systems that we are designing and deploying. And the way I think about it is there are a number of low-level tasks which are more tactical, transactional. You, instead of doing it yourself, you get AI to do it. There are obviously more high-level macro tasks. You have an interesting business problem you want to do more deep research on. You actually use AI to help you and augment your research and thinking, oftentimes acting as a sounding board. So in all of the diverse set of things that we do, and maybe we start, Prathamesh, with you. There are different ways in which I know you and the team are using various models on a day-to-day basis.
Yeah.
What is the framework that you apply, or do you have a mental model where you look at LLMs as part of subsystems which are both tactical, like a Swiss Army knife, but also more strategic for some of the larger tasks?
Yeah, I think you put it rightly. There's this low-level tasks. You don't need to worry about formatting your email, for example. Just write what you want to, and Gemini will take care of formatting. That's one. Categorization. So you want to classify, which we often do for various things. We have 1,000 categories of places. We want to categorize into 20 good categories. We can use LLMs. Maybe we need a slightly bigger model. But these are sort of very structured tasks where you can use LLMs to do it. Writing small coding blocks, maybe like very small functions, which are again checkable. I'll come to maybe like more complicated tasks. Again, these are something which I can do it. And I use Cursor for my coding. So one thing I do is, I mean, you can do Command K in Cursor, and this prompt will come up when you're coding this thing, and you just type the prompt and it will give you this thing. I have a text file open where all my short prompts are in a text file, and I'll modify my prompts and then use it. So it just, I think I'm slightly faster doing it that way. So that's just all sort of low level tasks. Another sort of interesting low level task that we do often is, there are sort of features that were not, we could not previously use them for machine learning models. That feature engineering was very hard. But a lot of this unstructured text, I mean, Sumanth will know, we can now use it as features because LLMs can read through it, give it in a nice structured output, and then you can use like a supervised model. So these are some low level tasks that I use LLMs for. Maybe I'll keep the high level ideation short, but I'll just give an example here. At a high level, if you want to go from point A to point B and you sort of know what the way to go about that is, but maybe you're not trained in a particular area to know the specifics. That's where I think LLMs tend to be handy. Taking my example, so by training, I'm an information theorist. So, and sort of computer vision is a very different field, but what you need, the basics that you need to understand computer vision, I think any grad school, any specialization will cover it. So, but one of the first IPs we built was something around images here. We built our own sort of model. And the way I went about doing that is, I knew what was point A for us, what was point B for us. This was just creating some meaningful representation of spatial images. And then I used LLMs to iterate through the literature faster than I would have without LLMs. So I think it just allows people, have said this, if you have high agency, LLMs can just give you a part to do things. So yeah.
Sumanth, what has your experience been?
So one of the things when ChatGPT really came out was mostly text-to-text computation. I mean, basically the text-to-text completion that what we used to do. We use that very extensively, whether it is unscrambling a particular address or really solving some customer problems. I'll touch upon the real-world problems little later, but how I use is that it is as a companion. It is actually sitting out there, can literally ask it to do any kind of research, refine anything that you would want. One of the simplest thing that I try to use it is that you want to really adopt a particular style, rephrase this into a particular style, and we should be able to really get it. Coming to the real world use cases, LLM, one of the interesting things with using these frontier models, it could be any frontier model, is that it can actually work with partial information. So what does it really mean is that earlier we used to struggle if a particular string is missing or if the placement is wrong or anything like that. Now the entire thing can be jumbled. For example, one of the use cases that what we use is you have a million jumbled addresses and you would want to convert it into some kind of a format which you can actually use it for processing. So this is a pre-processing where we use one of a smaller model which we have specifically trained to understand this in a particular context of Indonesia. You can use it and extend it to any context. Just that you train it on a particular context and then you can actually give it to LLM and then it performs very, very well. Like 95% or more is the accuracy. The advantage is that here LLM is really learning the patterns and not any specific rules or anything like that. So you take in a real world scenario, you take a system where you are not actually bound by any rules, or rather LLM is actually discovering patterns and then constantly applying and then constantly continuously learning it. So this gives a very tactical advantage when you are really solving a problem which actually needs some kind of a rule-based system, and you don't have to really write any more rules. You just have to, all you need to really do is to train a particular model, or you just use some of the frontier. So these are some of the things that we specifically use. Two things that really come to my mind when you are using LLM is it can work with uncertain data, means there is no 100% certainty. Whatever with bits of information it has, it can actually give out, very good set of information. And the second thing is that the ability that it can actually discover newer and newer patterns, what you call it as emergent patterns.
One other thing which is also interesting, which I'm sure you would have a thing or two to say about, is that it's not when ChatGPT came out, it was GPT 3.5, it was predominantly text and next token prediction was text. Now the way models have rapidly progressed, it is become multimodal as well. So it's not just generating or playing with text, it's also perception. So it can see. And that leads to a lot of implications as well. So you don't have to restrict it just to the spoken word or thinking, but also reacting to the real world.
Reacting to real world. One of the very interesting thing is the native multimodality that has really come out. Earlier, you need to supply it in a specific format. For example, if you take a picture, then when it was limited to text only, then you supply tags by processing all these pictures. But now you can actually generate a picture. Let me give you a very straightforward example that what we really tried out today is that I want to really find out all the opportunities given a particular retail store. This is a very interesting thing. Can human beings really solve it? They can really solve it only if they have the context of that particular region. So what we have actually done using the capability of multimodality and providing it is, you have taken an image which is actually view from one of the map providers, and then you have put that image, which is one side you have an image, then you have what is called as spatial structures, which is nothing but a neighborhood graph that what we have really built as a part of digital atlas. And the third one is the specific store. And giving all this information together, we are able to really say that, okay, these are the new opportunities that you have for these set of product categories or the product themselves. For example, how do we can predict where we should actually sell fresh milk? This is very important, and it actually takes in consideration of neighborhood, what the neighborhood looks like, what would be the possible income, everything which is embedded in a particular image, and then it is getting. And native multimodality is extremely good because you are now representing knowledge in multiple forms rather than on just restricted to text. You are no longer restricted. And coming to video, it is even more powerful. You can actually put out a video out there, and visual encoders or the vision models is able to capture that and able to detect. Earlier, we were easily detecting P-voice or anything. Now I can actually give you a sense of what is the storefront visibility, and I can even compare storefront visibility to multiple other stores that is in the neighborhood. So these are some of the things that LLM can easily do it. Not much of a prompt engineering, no zero-shot examples, nothing. Pretty simple. You can actually run through it and you will get the results.
So one of the interesting things that the more traditional, call it purist stats or maths guys or machine learning engineers, and you guys are, I would say, represent that fraternity, have to say is that it's almost like a gradient in the sense that LLMs are really good at things, but they are not the be all and end all, and there is still place for traditional machine learning applications as well. Madhu, you've seen a lot of this over your long career. For someone, of course, someone who I would categorize, let's say, as a purist, how do they think about this? And then also equally important is for someone that, as a young, let's say, engineering graduate that is coming out and is starting to think about, building things, how should they think and perceive LLMs as a capability? And given how fast it's growing, not just what it can do today, but potentially what it would be able to do in the next 12, 18, 24 months.
So to answer your question, let's sort of answer the second question first. LLMs, where they are today, it's still very, very early days. Right? So LLMs solve a lot of problems where there is enough data. Now, there are problems for them with on the fringes for which there is no data. For that, you still need the traditional techniques, right? Traditional deep learning, traditional. The trend in the evolution of LLM is going to be how to take these fringes, models of these fringes, and embed them in an LLM. That could happen through function calling, could happen through the verification process. There are a whole bunch of things. The ecosystem around the LLM architecture is evolving. So if I'm starting today, let's say I just graduated undergrad, looking for something to do, the question is, are you going to add to the LLM stack, or are you going to add to the Fringe stack? Now, a lot of the real world problems, they're deploying LLMs, the value is in the Fringe, the last layer. So more if you join an enterprise, anybody else other than if you go work for OpenAI or Gemini, other than that, everywhere else is the Fringe that matters, the last mile. So you need to sort of understand LLMs in generality, what can they do, the APIs of the foundational models, the open source, DeepSeek and all that, good enough. But modeling the domain knowledge to embed into an LLM. What does it take? How do you model it? That's the key piece. And getting through that method. The process of how to do it is still evolving. We do not have a handle. But that's the work in play.
But even though you're calling it Fringe, it is a pretty large surface area because...
Correct. For the LLM guy, it's Fringe. Right? But for everybody else, it's the most important.
But even on that Fringe, there is potential ways to use LLM as subsystems.
Yes, LLMs will become the interface to interact with the models that form that fat tails or Fringe or whatever you want to call it. Right? For example, very simple example, right? Tesla, the full automated driving pilot, works well in US roads. How well is it going to work in Indian roads? What does it take? Look, it's not Fringe. There's a whole bunch of stuff that needs to happen. Right? What does it take to adapt that model? Should we build a completely new one? How do you make that decision? Right? Nobody follows rules here. How does it work? Right? So these are all things that have not been figured out. So an ideal world has been assumed, it works in that ideal world. So the examples everybody talked about, primarily, if you behave like the ideal world, you will get the ideal result. If you don't, you're all over the place. So there's enough to do around this. Build the intelligence. There's so much scope. Every problem, if you look at through the eyes, or like I gave the recipe example there, to get the right answers, you actually have to do a lot of work. So I think there's enough to do. And the key thing is you also need to, as a person starting off, you need to wear your hat as a software engineer and as a domain engineer, whatever that means. You haven't even talked about it. What is the actual problem you're solving? So sometimes it's good to stay away from the LLM and just use the LLM like a black box. See if it works, doesn't work, why it doesn't. And how to get it to work, give it to somebody else. The LLM evaluation, AI evaluation, we'll talk about this later, but it's a big thing.
So going back to the examples that you guys were also giving, if you had to speak to a young engineer that is quite fresh and doesn't have a whole lot of, let's just, for lack of a better term, call it baggage of doing things a certain way and have to unlearn. It's a fresh start. What would you very succinctly tell them about using LLMs or AI? And it's not just using cursor, because that's obviously, or Claude. It's not just coding assistants, but how do we make sure that when they are coming on board, they're thinking about AI as a companion that goes beyond just helping them automate some code?
I would say maybe So one gripe I have with just maybe young engineers joining the team is LLMs. Using LLMs
You
doesn't
do
mean
have a lot of them in your team, by the way. So
Yeah.
choose your words very carefully.
using LLMs doesn't mean that your brain is on autopilot. Like you just so that leads to the term which is becoming popular now, AI slop.
Slop.
You will have 600 lines of code outputted, which is even harder to debug than just writing clean 100 lines of code. So, I think you need to keep it on leash, as people have said it on Twitter, multiple people. So just keep verifying things. I would say short, sharp blurbs. You can ask LLMs to do it, but then keep checking it out. Uh, and and I mean, I won't probably be exhaustive with this, but there are certain things that LLMs are good at. I mean, this used to be true, maybe not now, but a few months ago, LLMs were a lot better at Python than sort of other languages, right? So maybe now that's not the case. Recognize where you can use it. If you're using a very niche library, don't expect uh, LLMs to get all of it right. I think at this point they'll still get decent number of things right, but yeah, so I would say just the key for me would be just to keep it on a leash and just use it for maybe short.
Do you recommend, Sumanth, any kind of a mental model or thinking framework for young engineers who are starting as to how, I mean, you mentioned some of them, like if you're dealing with partial information, or let's say you have to handle unstructured data, you can use these models. But is there some kind of a mental model that you have or that you recommend to the team that think like this when you are evaluating whether to use LLM and to what extent?
Yeah, one of the things is that LLM, at least in our teams, in everyday usage, has become universal. Like we use it for every task, except for writing on Slack. We literally use it everywhere. Because we don't use it. Even when we would want to really do any kind of documentation, we do. But I would really put all the things into three buckets. One is you'd want to do any kind of customization. Like I gave an example, like you would want to really write a nice documentation for a particular thing, or let's say you want to write a design documentation, write a crude form, you customize it, make it into your own style. LLM does it perfectly. But the second or the two fundamental things that what you want to touch is, given any kind of problem, there are two things, whether it's an application or you would want to solve it at a more fundamental level. I'll come to more fundamental level, how some of the things that what we have learned with LLM can help us. But more interestingly, how you can actually make use of these applications. Like Madhu touched upon the Fringe things, what I call it as an applications, where you are actually using LLM not purely as a black box. You get hints of how things are working and what it is good at. For example, we tried a particular use case where you would want to really get all the data for a property. It's a hotel, or it could be Airbnb, or any kind of thing. And the task is that you would want to really take data from, let's say, 150 sources and be able to aggregate it, make some kind of a meaningful set of attributes, and then basically deliver that to the customer. But it actually misses one important step called as a validation step. In every step, you have now introduced LLM into it, and it's a pure application use case. We don't have to know how the internals or workings of LLM. So anyone onboarding can actually start picking it up in any of the phases, whether it is scouting or whether it is aggregating the information or whether it is validating it, and then start using LLM. Just someone has to be mindful of what model that they use, and that purely comes from experience. You just need to use these frontier models, the smaller models, fine tuning some of the models, and then you will really get there. So that's on the application side. You can actually use LLM in every phase. I have, by the way, I have written entire applications without any, not even single line of code. Z is a great browser, and you can actually write entire application, and it sticks to its particular set of given specifications, and you can write entirely. And again, they are great in Python, not so great in Java, Rust. Nothing great in Python, and you can write nice UI interfaces also. That is something that we have figured out. We
all
it's a low
our
cost,
disputes are
and then you can actually do it.
Yeah.
The other way is to give it little bit of a seed. For UI, this is the seed, like make a picture, write a drawing, and then give it, and it will be able.
Yeah.
Now coming to shifting gears to actually a different realm of how do you use LLM as a technology in more at a fundamental level. Like you actually LLM, what you call it as, really made this very idea of attention and transformers architecture very famous. although the deep learning existed, we have tried multiple things in deep learning, especially in image model and many other things, but it was never famous until we got to know that ChatGPT is actually using the attention models and the transformer architecture. So this very idea that you can give an attention to any kind of sequence is a very fundamental thing, and we can actually use it extensively. A beautiful example is that, let's say you pick a million transactions from a retailer and you would want to really see what is the churn. You can actually apply whatever we have borrowed from LLM, the sequence to sequence model, and add an attention network to it. And I mean, you really get some really crazier outputs. Just that, like Madhu mentioned, you also need quite a bit of data to it, because to train it, you really need this quantum of data to really achieve it. So these are the fundamental things. You want to customize, you can use LLM, great. You can do a fantastic job. Even if it is multimodal, like even if it's video, text, or it is some kind of an image that you would want to customize to your needs, they can do it. Use it extensively in applications, write as much as code, tune it. Actually, it is becoming, day by day, it is becoming better. I would really say that Anthropic is doing fantastic there. And the last one is more at a fundamental level, derive that and then use it. The last category, which is actually untapped and in the developer community, I mean, what are the teams that I have been, is doing the research. Let's say we want to do market research. One of the things I do say to developers is that it is not good enough just that you know how to code or how to use LLM, but know about the business. For example, today I want to know about some banking business because I have a use case that I'm really working on. Then you can actually go ahead and then use that. That's where the LLM as a companion really comes in very handy.
Just to add to Suman's last point, for a junior engineer, okay, write your bucket list of top 100 questions I would like to know. Best tool to sort of fire each of these questions and get a summary so that you are pretty much reasonably well educated in what happens at different ways. The specifics may differ, but it's much better than you searching for the right keywords to type in Google to get the right hits. So it really scales your self-learning machinery.
It accelerates in such a way. And always there's one tip there, is that you please always ask it for sources, because it literally can give anything as a source. It may exist or it may not exist. So you'll come into this habit that, okay, you ask for this source, be a critic, and then it actually gives you a pretty decent answer, and the research can take you along. I have actually tried and solving some very interesting problems in short amount of time, which can actually take, I mean, days to really solve it in very short amount of time with the aid of LLM.
Just one point. Suman mentioned something interesting. So when with the UI example of how do you give images and all, I think so. Maybe slightly to abstract it out a little bit, I think one thing that is coming out from the way we were using LLMs when we started out, right, and the way we are using now is just the prompts themselves have become more and more important. So to the point wherein it is a skill which comes with like using it, and we need to figure out how exactly the prompt should be. That is something that people need to pick up. It's a new thing. It's not coding is one thing. This is just something that is emerging. You need to figure out how to write good prompts, and that's towards my cursor example of keeping the prompts in TXT file and then sort of using LLMs to refine them further. But that's emerging as a skill. One final thing I'll add maybe to what Madhu's also mentioned is, I would say like basics still remain basic. So being proficient at coding, just being good at logical reasoning, math are still important. And there's a faster way to do that now with the way Madhu mentioned, right? You can just look up things using Perplexity, ChatGPT, and then read about that further. Yeah.
You talked about a lot of the interesting ways in which we can use LLMs. What we also touched upon at different points is they do have certain shortcomings. There are certain challenges with LLMs. Obviously, one of them being the fact that it makes up stuff, it hallucinates, tends to agree, can be quite sycophantic in nature. What are some of the limitations that you guys have personally experienced while you work with it? And also, a larger question thereof is going back to something that we have discussed in the past as well, which is this is the whole AI evolution seems to be branching from middle out, in the sense that you need to do a lot of work upstream to prepare the data, to do EDA, to do some kind of fine tuning. If you're ambitious, you do pre-training. And then downstream, there is, because of some of these shortcomings, a significant need to, and a massive gap in the market exists, which is to verify. Back in the days, not that back in the days, but software testing was a very well-defined process because software itself was a very deterministic, bounded, well-defined thing. You could go through a few steps, you could test, and you could say that, okay, this tool works, works well, it's tested, it's ready for going live. That same thing doesn't work in AI. And a big part of the challenge there also seems to be, with a lot of the work that we have done, is that you can't use just AI to validate itself. It's not that straightforward. So drawing on some of the experience, Madhu, that you've had from your past life, how should we, one is of course the shortcomings, and do you see some of those getting plugged, and how soon? And I know you have been a bit of a skeptic when it comes to LLMs from pretty much from day one. But also on a related note, how do we think about validation, verification of AI systems? Because to me, it seems like that is one of the biggest roadblocks in AI adoption, especially when it comes to enterprise AI, where a lot of their processes are mission critical and they can't take any chances.
Yeah, so just food for thought. The first OpenAI was launched, GPT 1 or 2.5, June of 2018. Right? So it's 7 years now. So if you're just across this table, I've asked the question, what is the mission critical application that are completely handed off to an LLM based system?
I don't think there is one yet.
No, it is zero. We cannot.
Right? So given that, so now that's whatever the reason, it's the last mile hallucination, one-off hallucination. So it's scaled a lot of work, but you still don't trust. As a society, we don't. As long as there's a human in the loop, we are fine. Now it's good for embellishing or improving as a human, but many systems, automated systems, a lot of work needs to be done to make sure that the use cases and the variants in it are well bounded, your guardrails, this, that, all that stuff. So the engineering work actually to build a system with LLM embedded has sort of increased manyfold. Engineers need to learn the behavior of the LLM first. So a product manager asking him to spec out so that I can write a software functional testing is just not happening. The functional tester's problem has magnified 10x, 20x. Because now he has to know so many things, which even the product guy would not have defined. So the notion of even testing has now become AI evaluation. Right? So we have just complicated, where our engineers had, it's made our lives extremely complex. That's why billions are being made. That's one side of it. Other way to look at it, as an engineer, I'm very happy because there's so much opportunity. There's so many problems to solve. It gives us new ways of approaching problems, especially the whole vision LLMs, what we just talked about earlier. There's a lot of problems that come under scope that we can attack. We didn't have a way to do it. So that's sort of both sides of the coin, right? So now coming to specifics in terms of hallucination, reliability, fundamental thing is AI evaluation is extremely important. People have realized the complexity and they are adding sort of verification in the loop. Right? Verification in the loop works well if the world is well defined for playing chess or playing Go. Right, where the model is well defined. But if it's open loop, there's a real world system that's going to change, even for a robot. Right, it's assuming a part is here, the part is misoriented for whatever reason. That becomes very hard. So now many systems are going to be worked at this last mile level where verification, validation, and human in the loop for specific scenarios where you train by simulation and things like that are going to be. And how do you set this up and capture this? Which is what the focus is. The physical AI, all of this. Natural language, those kinds of systems. Natural language is pretty reasonably well handled. Video sequencing, interpreting from video is the next sort of boundary that people are attacking. And another 2.5 years, we'll see a lot of progress. Then comes how do you synthesize language and vision together to do something? Can I take commands to do something? Yeah. Right. So I think, and all of this is going to depend on it. So human skills, not only for labeling, training data, actually doing things is going to become very, very. Right? So training in the loop, how do you train? What do you capture? What do you validate? All of that is that is one side of the work. Another side is, are these just sequences? How do you reason? So reasoning with all these modalities becomes that much more complex. So which is where sort of you see the JEPA architecture and all. New ways of using transformer architectures to attack. So I think there's going to be an explosion of all of this in terms of, so it's a great time to be in AI R&D. Now, what does it mean to become is it a great time to be a product manager or a product person or in actually building products and that, that's still to be seen. Right? So that is where it is. And we still have to find sort of classes of applications and systems where this will work well. It's good for training. Anywhere where human is involved, great. Right? As long as the human can correct. Even if it gives the wrong answer, it will correct it. Even if it's a bad text, bad email, you will edit it. And you'll blame yourself because you said you gave the wrong prompt. Right? So that part works. Can you put in a black box and say hands off? Not yet. And I don't know how long. Is it 5 years, 10 years, 15 years? But to get these systems and empower humans, there's enough to be.
We've done a fair bit of work on validation, and we've gone through a whole host of challenges where it makes up stuff, it tries to give the ideal answer saying everything is perfect. What has been our learning, and what is our final conclusion that where are we now?
Yeah, so one of the experiments we took in solving one of the use cases is that you have lots of data out there in internet, and you methodically really get all this data. And this could be something like a blog written about a place, or it could be something about user opinions in form of reviews or anything. And you would want to condense it and summarize it into a very simple set of sentences that you can actually tag it to a property or a particular place or anything. It could be any landmark or anything. It's a very simple use case, but here the problem is how LLM can become opinionated, number one. And second thing is that how LLM starts to generate from its own knowledge, which is actually very dangerous.
Yeah.
And it may not be like what is actually written in text. So this actually comes down to, like Madhu said, is that how do you ground LLM in a particular knowledge set rather than saying that randomly generating, because ultimately it generates lots of text, and of course there is a mechanism for that, but how do you really ground is the basic question even before you actually go to the validation phase. So what we have done is we have actually created citation models where you have citations for each of these particular sources and then broken down into what we call it as concepts. So this is something that what we have introduced, and given an answer, how it is in coherence with these set of concepts is what we measure, and then tell whether LLM really hallucinated at the end, because you cannot track LLM throughout the process saying that, okay, it generated this much of text from, let's say, 150 sources. Now 150 sources actually makes it into a certain set of concepts, and these concepts now we can actually tell that these answers are grounded in this concept. The very simple example is, let's take, there is a particular place in Cairo, Egypt. There is a nice hotel. And one of the things LLM says is that the best way to take your shot is behind a pyramid in a sunset, basically in the golden hour. Now, how do we really know this? This is a very interesting thing. So a lot of images are available, and you can actually use them to really tell that, okay, you can infuse that into LLM and it will generate. So when these images and blocks we have, there are sections of blocks which actually tell that you can actually go out in the golden hour and you can get a nice view, I mean, nice picture of yourself and the pyramid in the background. You're actually having a nice concept. And this actually translates, or basically we are grounding in this concept, and we are testing against this particular concept that, okay, this exists for this particular knowledge, and we can now validate. So now we have built a validation system which can actually ground, or basically to verify everything, is it grounded or it is not grounded. And we have found multiple things where LLM has just like hallucinated. Yeah. There is a hotel in Norway which LLM says that you can just meet, if you go in December, when they start announcing all these Nobel Prize, you can just meet Nobel Prize winners. Actually, it is all incorrect. It is coming from some other sources, and with our validation thing, we are able to really be able to find. Yeah. There are two main problems in what we have discovered: grounding and consistency. If I run the prompt, the same prompt again, it actually gives out multiple answers. Yeah. We have tried with Disneyland. It gives out like hundreds of different set of answers. But now with this, we were able to achieve the validation, and you can come up with a validation score that is associated with each one of them. And because now we are grounding it, we can now tell, and then, I mean, we can tell that synthesis of knowledge is mostly correct. And then we still be able to tell that, okay, this is more factual than what you actually think, although it is generated by it.
How do we think about some of these shortcomings, and how do we overcome them?
The way I think about validation or verifying thing is, one sort of basic principle I have in mind is I mean, this is sort of classic computer science principle is querying is a lot cheaper. Querying existing information is a lot cheaper than searching new information, right? That's a much computationally lot cheaper. So you get LLMs to give you a first set of results, whatever they may be, and then you use another sort of verifier, can be another LLM. It could be, I prefer if it's like a more deterministic tool, but in some cases it has to be another LLM to just sort of go through all the things that you've searched and just verify them. Uh, for example, we are sort of building this digital atlas live where we want to understand what are sort of events that are going to affect a retail store. We can do our initial scans, which are automated, and we get all the news events happening. Not all of them are going to affect it. So we have this verifier in loop which checks for distances to this thing, which can be deterministic because it's a spatial operation. But then there can be some temporal operations where you need to again search the news. So a high level framework I have in mind is querying is uh, cheaper than searching. So you build some querying pipeline and let LLM give it. So that's how I think about it. The other thing is, I think uh, there are cases wherein just uh, giving LLM concrete examples of what do you. So another issue, I mean, with there can be sort of binary answers sometimes. Is it right or wrong?
Yes.
Sometimes it's a calibration issue, wherein if I give uh, a certain cricket player a score of 7, then I want some other cricket player who averages uh, subjectively to us watching does similar performance. We want them to be given the same score, but if you give their data to LLMs, they might just come up with different scores.
Yeah.
So how do you then make it calibrate? There can be maybe fine-tuning methods, but I think even just giving concrete prompts with multiple examples that it can learn from works well. So incidentally, we applied this to something that is archived now, tracking urban development. We have sort of a LLM system built in to track sort of urban development in the region, and it's not that it's sort of fairly efficient in terms of cost compute. And the way we have been able to do this consistent scoring is just by uh, giving it multiple examples to learn from.
You have some kind of a deterministic way to verify things. That is one thing.
Yeah.
So all the random probabilities or little bit of an indeterministic system that actually LLM throws at you, it needs to be grounded in something
Yeah.
which is deterministic.
Yeah.
Right? The same thing.
Yeah.
Let's say you want to find a nearby place.
Yeah.
So I take one property, again the same Cairo property, and then I would want to see what are the nearby activities. It cannot just say you can go to a starship or anything like that. Of course, LLM can say that. You will never know. But it should actually tell you that there is a pyramid and you can actually go to a pyramid because it has that spatial knowledge. Now that there is a pyramid and there is an entrance to the pyramid right next to that particular hotel, how do you really know that? We can actually query a set of places database that we can actually tell that, okay, there is a entrance to that.
Yeah.
And there is very interesting thing is that if you start basing everything in a deterministic set of what I call elements, not just facts, then you can generate or make LLM to generate anything and you still be very sure that it is really the right thing. Nobody how many times ever check it out, it is the right thing. That also gives you some kind of a consistency. That is also one of the factors that is. So this is the general rule that what we follow. Bound everything. Literally you have to bound and make everything be grounded in something which is deterministic. But if that something is not deterministic, like I give you 10 blocks, ask it to generate some summary, it will generate. I mean, the frontier models are damn good. They are really be able to generate. But at the same time, there is a small chance that it can really infer something on its own and it can really go off the, what you call it as, off the rails. And if you leave it all alone like black box, it will be generating something else. Just for a reference, the first time when we did this scout aggregate gather, we took 11 versions to reach the goal. Then we started grounding in. We took just 3 versions and we are like done, like perfect.
That actually brings me to another point, and this is the debate that's happening around AGI. And once we get to AGI, then the fringes will disappear because the models will be able to do everything. I feel that people that have not necessarily sold to any enterprise or done actual large company B2B deployments have this notion that AGI will help solve problems. But from where I see it, every organization, large or small, has a number of nuances, which is, and I would categorize them broadly into 2 or 3 buckets. One, there is always data, which is very, very unique to every organization, to every industry, within organizations, to every team. Second, the roles, responsibilities are a function of the team or the domain within the organization that you're speaking to, whether you're speaking to the sales team or the marketing team, the supply chain team, the operations team, the technology IT team. And it's very, very unique to that organization. Again, and thirdly and finally, and probably the most challenging piece, which I'm sure anyone that has sold to enterprise would agree with, is the personnel or people nuances. People are unique, people are different. At the end of the day, how do you automate or bring the nuance of how you deal with people? And especially when you're selling into enterprise, you're not dealing with one person, you're dealing with teams of people and a whole lot of the dynamics of different teams and different people amongst them. So Madhu, what are your thoughts? You've been, again, around the block long enough time to see a lot of these cycles of boom and bust and speculation. And when people say, and there was this recent conversation on X as well, where this came up, that once AGI comes, then we'll not have many jobs remaining. Even in enterprise, we'll be able to solve the problems. What is your view on this?
I think given the skeptic I am, we are a long ways away from AGI. So everybody's job is pretty much secure. At least you'll get a job doing AI evaluation. Okay, so for sure. So I don't think anybody should worry about it. Now, coming to enterprise, different kettle of fish. So first question is, see, the interesting that your question is relevant in the context of what's happening now with all the foundational model guys becoming vertical companies, right? For example, OpenAI is hiring a whole bunch of financial guys out of Wall Street, paying $150 an hour to build a financial analysis model. But still, the everyday day trader is not going to rely on this. If you go put it on OpenAI, everybody else has the same form. So my magic sauce is the same story for an enterprise, right? So even in a sector, in an industry, your core competency, you may automate, you need to figure out, or you may have people specific, you may not even want to automate. It's like having a poison pill. I don't want to put it on a system because I don't want to scale it. Many ways this is going to evolve. You don't know it. But the point that my data is unique, I sort of, over the past decade and a half working with data, yes, your data is unique, but how much of that data is really useful? I don't think enterprises yet have a hand on which percentage of the data is useful to understand the past and to guide the decision making for the future. This boundary work, many enterprises, it's been more a technology driven thought process rather than a top down. And with the LLMs and the current AI technology is really pushing people to think what is really useful. Do I really need all the 80%, 100% of the data, or do I need the latest 20%? What is unique? What is not? So these old questions are come back in a very different form. So any enterprise that spends the time working with the right consultants or whoever to define this is way ahead of the game. You don't need to automate. But first you need to know what you have. Is it really worthwhile? And are you collecting the right things? Maybe you're collecting all the wrong things. So I think this rethink is a thought process which much of the enterprise leadership isn't used to because they've been used to buying technology off the shelf and deploying. It's just not the case with the game of AI.
Yeah.
So I think that's a big major rethink that's happening, and that I don't think there is a single sort of solution that is going to solve this. Right? They need to work through. There's enough work to do in enterprise. So then comes the selling, the people, the understanding. And I think the notion that AI is going to automate, no, you actually need to use AI as a tool to empower your people, make them better, make them understand.
Yeah.
So it's going to be a different kind of, because even in the past 2-3 years, many companies have laid off people, they've been brought back. An actual value is created in that last mile where AI systems. So I think that dynamic is going to play out. And I think much of what we are going to do, my gut feel says, is still going to stay. People need to get better. People need to get better at their job, whatever that. Again, the notion of a job, how it's defined may change.
It's interesting you say that also. In our experience, we have had wide-ranging conversations with large organizations. There are some where we've had conversations where organizations have said that we want to, which is more of a capitalist way of thinking, which is that we want to figure out how to use AI to cut costs. And if that means we have to reduce our workforce by 30%, that's great because that improves our bottom line. We've also had conversations with very large enterprises where their view is that we want to use AI, but we want to use it in a way where we don't have to reduce our workforce, but we upskill them, we move cost centers to profit centers, and we do it in a way where if you're employing 100,000 people, which is very important for this country's economy, we don't want to reduce that workforce. So it's a very interesting different ways in which people are trying to optimize for different things. Obviously, they know that AI is real, but how do you optimize and what impact that leads to? Coming back to one other thing which we touched upon briefly, transformers as an architecture has, it can be applied, if I were to summarize what Sumanth you said, stream of or a string of events. It could be, obviously it could be tokens as text, it could be transactions, it could be, you're buying certain products on e-commerce platforms. The attention framework could be used, but it doesn't seem like it has been used nearly as much as this intuitively makes sense, but it doesn't seem like it has been applied as rigorously in other disciplines. Why do you think that is? And also the segue, the follow-up to that is, what do we look at the next generation of architectures which come after transformers? Because I'm sure there's a lot more work that needs to be done where we improve this architecture completely. There's enough and more work that's happening where people are using diffusion as an alternative as well. There are some early signs of that. So why hasn't this been applied more than what? It doesn't seem like it's become mainstream in a lot of other data sets of discipline. Why is that the case, and what do you think happens next?
So let me just touch upon two things that we have actually tried. One is churn prediction using the sequence to sequence model with attention embedded into it, and it worked pretty well. And I will tell you what are the limitations. The other one that what we have used and we have been fairly successful is in understanding urban spaces using some kind of a graph network where the places, the neighborhoods, and its attributes are modeled as graphs. So one of the major limitations that what we see is the amount of data that you need and also the compute that you need. For example, you go to an enterprise and let's say you take 3 years worth of data, and one of the things that you will not have it is that you will not have how do you go to model the temporal aspects of the data if you want to use sequence to sequence model. And it's not very easy to put in the dates and special events that really happen for the transactions. Let's say a retail is buying a set of things and then you want to apply that. That is one of the limitations that what we see. Beyond any of these, it probably did not catch because that you need enormous amounts of data and also you need enormous amounts of compute to really get anything out of it. We have tried diligently in the churn prediction models, but it takes like a lot of time. But once the model is ready, still you need a lot of fine tuning or anything for it to really respond to, let's say for this. The question is whether this sequence will lead to churn or not. Nothing is deterministic. So those are some of the limitations that what we actually see in all these things. I really feel one of the things that what progress from here is that use of more and more graph models and then applying some kind of an attention network to it so that you now see not just as isolated set of events or anything like that, but you see actually that as set of nodes and you can infuse some kind of multimodality into it. And we have been fairly successful in grounding all these things into some kind of a graph network for an urban space. Take an image, put it into as a node, take a place, put it as a node, and then model that relationship. And I really feel that the graph attention networks will go a long way if you are able to model almost everything as a graph.
But do you think there are new architectures on the horizon? Where do we go from here? Potentially?
Yeah, I think so.
There are new architectures. The more interesting question to ask is, as experts in a field today, how much of each of our knowledge was based on large sets of data? See, fundamentally, our 400 years or 500 years of science and so on has focused on the principle
Science,
of.
by the way, Madhu, I think our roots are science is much longer history in
No,
this
not that
part of the
long.
world as well. Right?
No, I'm saying no. Even in the 500, 600 years, we follow the principle of the simplest explanation is the better. Smallest amount of data, smallest theory, right? Outcomes raised. No, suddenly you say there's no equivalent of Occam's razor for big data. Right? But this is the first place where we have access to laid off data. We are, in most domains, doesn't exist.
Yeah.
Right? So that whole theory building process around big data and all still early days. Right? So then there was the past 6 months, 12 months that's been pushed towards SLMs, right? Small language. What does that mean? How do you bound it? Right? So in that, how the architecture is going to evolve is going to be interesting. You still don't know. We are still out. Where do they work? Where do they don't work? Will they work for specific things? Right? I can imagine an array of LLMs solving certain problems, not one big model.
Yeah.
Right? So the architecture may evolve very, very different. A lot of that still needs to be exposed and experimented with. So much work to be done. Right? But as a even just for the sake of it, evolution, right? Our memories are not infinite. Right? We tend to forget. We don't know why.
Yes.
We could have had a big data machine. No, there's no big data, no storage. You tend to forget for a part because what you need is a very small amount to make an intelligent decision.
Yeah.
Right. So I think the need to know everything versus the need to know something specific to do a task. The top level, I don't think we still have a generic understanding of what it takes. So why model everything and confuse ourselves? So this whole hallucination, because you know too much and you're bringing it in the wrong place at the wrong time.
Yeah.
Right. So these are all bigger sort of cognitive science issues that have not been seen. Right? We are looking at it from a very engineering perspective.
Yeah.
Also, you brought a very interesting point as an array of LLMs. So we have experimented with that, where you don't take one large model to solve some kind of a problem. If you are given a problem, there are only two things that what we discovered is very important. One is decomposition and finding a set of what we call it as an expert. For example, you train a model expert in spatial sciences, train a model which is, let's say, it is very specific in understanding the weather nuances. And let's say there is a specific expert which actually understands the neighborhood nuances. So we combined all these things together and then ask it what would be the impact with an increase, let's say in nominal, or let's say the fall in temperature, given that the weather prediction in New York is like this, then what is it? Then each of these are actually solving subtasks, and the main brain, what we call it as the cortex, is actually handling all the orchestration and actually basically combining all these things. We call this as what we call it as an experts in each of the area, experts in weather, experts in neighborhood, experts in spatial sciences, trying to come together and then solve. This array of LLMs actually work, and also this is very simple in the sense that you don't have that huge model trying to understand everything and hallucinate and lose its way, rather than it's small subtasks that it actually really solves, and it works very well.
Yeah.
It's quite, actually, when we go through this process, you start to develop a much deeper appreciation on how sophisticated the human brain is.
Yeah.
LLMs memorize everything they see, but humans obviously don't. But we're still able to make such nuanced, mission critical decisions with very limited data points, and it's very challenging and hard for an LLM to do the same thing. It also almost makes you wonder, with the amount of capex investment that's happening into data centers and energy, etc. What if there is a new kind of paradigm architecture that comes along which says that you don't need all of that? Actually, you can make highly specialized models which are very specifically trained, and they have high performance in terms and very energy efficient. And then what happens to all of this capex investment?
You hit a valid point. That is still going to come. But there are folks who want to know what's happening in the world. So there's the whole observing, monitoring angle. And it's not about local decision making for myself. I want to control I want to know where the whole country is going. For them, this machinery makes sense. Right? So I think that split has not happened. Right now, we're going to, if you had your own search engine, it would only be my dog. It's my interest. Why would I carry everything else? I don't want to know. So this boundary between local and the bigger one has not happened yet. Why do I want to be an expert in everything? I don't want to. Right? So this whole thing of how knowledge has evolved, still early days. Right? So that is where it is. So we have to, as engineers, we have to really ask ourselves the question: what are we using this for? What are we solving for? Right? And it's a good technology. I think we have done something interesting in the past decade. how to use it is still up for grabs.
So one interesting thought came to my mind as we were discussing here that humans actually can solve it with a lot of things. At least I make very interesting decisions with just bits of information. I don't actually need, and I don't know what exactly it is, muscle memory, I don't know. Or it is just intuition. I really don't know what it is. I call it gut. For example, you want to take an auto or you would want to take a particular car, that how much time it takes. I don't check maps. I just make the choice that, okay, in this case, car will be more comfortable or anything. Let's say in this case, I will easily be able to find an auto, and 90% of the times I'm really correct. I'm not bragging or anything, but it is correct. It is probably the gut. But I have never found that kind of a thing in LLM. LLM is a little bit process oriented. It goes through all the process. It doesn't shortcut or something, or maybe it shortcuts. I really don't know. But one of the things is that it doesn't do gut-based decisions. So anyone who's actually working on this weak core LLM probably can actually find out how do you really make LLM to really have this gut feeling, and so that it can actually make decision faster and no need of any expert or something.
Yeah.
And then it can actually breeze through all these things very interesting. It would be fun. Probably we can actually set up a small model where we can actually make it to make choices that using just gut feeling and see how many times it actually is correct or how many times it is actually wrong. I don't know. It's one very interesting thing that. But human beings, I can watch. I have sit with LLM for long hours here in this office. LLM takes a lot of your own brain power to really make it work. That is the truth. I mean, but it can be very good at repetitive tasks where human beings are not so great in it.
That's why it lost at poker. So we should not be using it at poker.
So if you can build a LLM which make gut-based decisions, then believe me, it would be really, really very interesting. Or maybe it is already doing. I really don't know how these frontier models are really working, but it could be very interesting.
So the team on Gunpoint forced us to match these greatest of all time athletes with different frontier models. Which is the fastest one?
The fastest Usain Bolt is Grok. The fastest is
Okay,
fast.
But Grok is also unfiltered, so we
No. Grok fast is very well grounded.
You pick one dimension for each person. That's it.
Fast.
So Grok is Usain Bolt. Which one is really the most skillful, the most artsy, messy? That would be messy.
have to be
Claude. Yeah, Claude is messy then.
Okay.
Michael Jordan. This is probably maybe Quen. I think it's quite versatile and good at a lot of things. So Quen is Michael Jordan. Serena Williams
This is GPT.
GPT probably.
picking out different attributes from the athletes.
Yeah.
Going for like more feisty from Michael Jordan, like proving people wrong.
Lewis Hamilton also is quite
Hamilton would be so.
deep seek. Hamilton is quite sharp at calculating. So.
People do Grok because he's also unfiltered. Like
Virat Kohli is Grok, yes. Yes, Virat Kohli has to be Grok, I agree.